Today we are solving 2021 Feb-March paper 42. Let's start with question 1. Two particles P and Q of masses 0.2 kg and 0.3 kg respectively are free to move in a horizontal straight line. Okay, let's start drawing the diagram. Particle P, particle Q, horizontal, one second, not a proper horizontal line. Okay. Two particles P and Q start to move in a straight horizontal line. Better. Let me draw P and Q. P is 0.2 kg. Q is 0.3 kg. P is projected towards Q with speed of 0.5 meter per second. Okay. So the speed is 0.5 meter per second. At the same instant, Q is projected towards P. Q is projected towards P with the speed of 1 meter per second. Okay. So this will be 1 meter per second. At the same Q comes to rest in the resulting collision. That means this is the initial velocity. And after the collision, after they collide, let this be before collision. Now, collision will occur and something will happen after the collision. Let me draw diagrams for all of them so that it is better to understand. So now this is during the collision, P and Q collide. P and Q collide. And then after the collision, what happens is Q comes to rest. What does that mean? That means Q, the velocity will be 0 meter per second. And P, we don't know what will happen to P. P will move somewhere. It can move here or here. Obviously, it will move to the left because if two particles are colliding, one is stopping, the other one will move to the left. If it moved to the right, then Q should have also moved. So this will move to the left now. And what will be its velocity? That we have to find out. Let that be x meter per second. So what we can use is initial momentum equals final momentum, or total momentum before equals total momentum after. I'll just write Im equals Fm, but in your exam paper, you'll have to write the entire thing. Initial momentum equals final momentum, or total momentum before equals total momentum after. So initial momentum will be 0.2 into 0.5. I hope you know the formula for momentum is mass into velocity. So mass of P into mass into velocity of Q. Mass of P into velocity of P plus mass of Q plus velocity of velocity of Q. Now, what you have to notice is that velocity is positive in the right direction. So if in this case, the ball is moving in the left, so we'll consider velocity as negative. So the momentum will be 0.3 into -1 plus 0.3 into -1. And the final momentum will be 0.2 into, now this is also moving in the left. So you'll have to take negative minus x plus 0 because the velocity is 0. So my momentum will be 0. 0.2 into 0.5 equals 0.1 minus 0.3 is equal to minus 0.2. Therefore, x minus 0.2 is equal to minus 0.2x. Therefore, x is equal to 1 meter per second. What does this answer mean? This answer means that P after the collision will move at 1 meter per second to the left. Now, what they have asked us here is to find the speed of P. So the speed of P is 1 meter per second. Hope in case it would have happened that you will not realize that x will move to the left and you will not take negative, you will take positive. No problem. This will be positive. This will be positive. The final answer you will get is minus 1 meter per second. But read the question again. Find the speed of P. Do you think speed can be negative? No, speed is never a negative value. Velocity is a negative value. So the final answer what you will write is answer, you can write this answer. Speed is not negative. Speed is not negative. Therefore, velocity equals 1 meter per second. And that's your final answer. I mean, speed is 1 meter per second, not velocity. Let's move to the second question. A car of mass 14,000 kg. Let's start drawing the diagram right away. Let's draw this car without wheels. A car of mass 14,000 kg is traveling at a constant speed. Okay, no need. Oh, so that's what I call being in a hurry. I did not read the question. I started making a diagram. Straight up a hill, inclined at angle alpha. So the diagram will look something like this. Yeah, inclined at angle alpha. The car's mass is 14,000 kg. So this will be 14,000 into 1 more 0 Newton. Why? Because mass is 14,000 kg. So weight will be mg, which is 14,000 into 10, which is 1,400 into 10, which is 14,000 Newton, which will act downwards. Why? Because weight always acts downwards. So mass this much inclined at an angle to the horizontal where sine alpha is 0.1. Okay. So alpha will be sine inverse of 0.1. And we know that inclined at an angle to an alpha. So alpha is sine inverse of 0.1. So if I put sine inverse of 0.1 in the calculator, the answer I'm getting is 5.74. So what I can write here is 5.74 degree. And there is a constant resistance force of magnitude 600 Newton. So the car is moving up a hill at a constant speed up a straight hill. That means the car is moving like this up a hill. This will be the driving force, some driving force. And there is a constant resistance force. So resistance will be in red. The resistance force is 600 Newton. Because the car is moving up a hill, the resistance will try to stop the car. So in order to stop the car from moving uphill, the resistance force will have to act downhill. The power of the car's engine is 2250 watt. Okay. Power. And what does this power indicate? Power of the car is nothing but it leads to nothing but the driving force of the car. So because the engine exerts power, there is some driving force that the car is exerting. That's what we need to understand. Now we need to show the speed of the car is this as much. So there are two equations first which I want to make sure you know beforehand. First is power equals force into velocity. But there are a few changes here. Power will be the power of engine, which is this, and force will be the driving force, not resultant force, not resistance force. This is why, because the power of the engine will only be able to exert the driving force, right? So that's why these both are related. So now that we are done with this, let's get ahead. Power of engine equals this, and the other one will be F resultant will be 0. Why? Because they have told that the car is traveling constant speed at a constant speed, and constant speed acceleration is 0. At constant speed acceleration is 0. F resultant is mass into acceleration, so F resultant will be mass into 0, which is 0. Hence F resultant is 0. So what you need to realize is any question which includes that the speed is constant, the thing which should come to your mind is the resultant force will be 0 because the acceleration will be 0. Now what will the resultant force be? The resultant force will be the driving force which is acting upwards, Fd, minus the 600 Newton which is acting downwards. Are we done? No. Why? Because the one thing we are still yet to write is 14,000 sine 5.74. This is the force acting down the slope due to the weight, mg sine theta. So even this will be included, minus 14,000 sine 5.74. Okay, so now we are clear with this much. F resultant will be this. Now, what we know is F resultant is 0. So instead of this F resultant, I can write 0. And now we can see that this FD is the only variable remaining. So FD will be 600 plus 14,000 sine 5.74. So the value for the driving force will be 600 plus 14.74. If I put that in the calculator, the answer I'm getting, did I miss something? 2,200, 2,400, and 600. 600 downwards, this downwards. Yeah, I'm clear. So 600 plus 14,000 sine 5.74. The answer in the calci which I got is 2,000, 2,000.2 Newton. So now we know power of engine is driving force into velocity. We know the power of engine. We know the driving force now. So we can easily find the velocity. Let me write that down. Power of engine equals driving force into velocity. Power of engine is 22500. Driving force equals 2000.2 into velocity. Therefore, velocity is 2250 upon 2000.2, which is 22,500 upon 2002. If I put that in the calculator, I'll get 11.248249. And so the answer will be 11.25 meter per second. That's what they have asked us. Show that the speed of the car is 11.25 meter per second. That means if the car is traveling at a constant speed, the speed at which the car will travel will be 11.25 meter per second. Next question. The car is moving with a speed of 11.25 meter per second. Okay, we know that. Comes to a section of hill which is inclined at an angle of 2 degree to the horizontal. Okay, so that means initially the inclination was 5.74. Now the angle has changed and the question is hence become new. So we'll make a diagram again. This is 2 degree angle. Same car, mass will remain the same. This is 14,000 Newton. This will become 14,000 sine 2 because mg sine theta value has changed. So initially what was 14,000 sine 5.74 will become 14,000 sine 2. And the normal contact force will be 14,000 cos 2, 2 degree. Okay, we'll go ahead. Given the power and the resistance force do not change. Okay, so resistance force we know 600 Newton. Power 22500 watt. So because there is power, we know that there will be driving force FD. They have told us power and resistance do not change. Find the initial acceleration of the car up this section of the hill. So that means that the acceleration is upwards acceleration. Now we'll go again. F resultant is equal to mass into acceleration. Can we equate this to 0 now? No, because there is acceleration now. So what will F resultant be? F resultant will be the mass, which is 14,000 into some value of acceleration. But what will the F resultant also be? F resultant will be FD minus 14,000 sine 2 minus 600. And what is F resultant? 14,000 alpha. So instead of this, F resultant is 14,000 alpha. So instead of this F resultant, I can write 14,000 alpha simply. So let me do that here. 14,000 alpha is equal to FD minus this. So now what to do to find the initial acceleration? We also know that power is equal to force into velocity. Now, what is this power? Power of engine. And what is this force? The driving force. What is the power of engine? 22500. What is the driving force? Driving force we have to calculate. And what is the velocity? The velocity is 12.5 meter per second. So this V can be written as 11.25. So by this we can find the driving force. The driving force will be 22500 upon 11.25. And if I put that in my calculator, 22500 upon 11.25 will be 2000. So the driving force remains 2000 Newton. So right here, instead of FD, I can write 2000 Newton. So 14,000 alpha is equal to FD. Instead of FD, I will write 2000 minus 14,000 sine 2 minus 600. So now alpha is the only variable remaining, and this 14,000 I can take it down. So it will become divided by 14,000, not 14,000, 1,400, my bad. So this 10 we'll have to remove. Even this 14,000 I can remove now. And the final alpha value which I'll get, if I put this in the calculator, the value for A, I mean acceleration I'm getting is 2000 minus 14,000 sine 2 minus 600, answer upon 14,000, 1,400. So the answer I'm getting is 0.651 meter per second square. And that's how we are done with this question. Let's move to the next question. A particle Q of mass 0.2 kg is held in equilibrium by two light inextensible springs. The strings PQ and QR. P is a fixed point on the vertical wall. QR is this. The angles are this. Find the tension. Okay. So let me label this tension as TR and this tension as PT. Now, many of you might have a doubt that why did I label the arrow like this? Why was the arrow not like this? So in order to find tension, there is only one thumb rule. That, for example, if there is a wall like this, and this is a ball, so the tension will only be in the direction which will face the wall, or which will face the horizontal ceiling or something like that, because the ball already has its own force, the ball or the object. Because of its mass, it will have the force of the weight. So because it has a force, there might be an opposing force which is making the ball stop. That will always move opposite. That will be in the direction of the ceiling. So this is the ceiling here, the ball, this will act downwards. This is the wall here, so it will act upwards here. So now that we have understood how to find the tension or how to find the direction of tension, let us move forward. Now let's label all the forces in this diagram. So one will be the tension due to the R, and this will be downward arrow, not upward arrow. So the tension due to R, I'm labeling that as R. So this force is R. And the tension due to P, tension due to P, I'm labeling that as P. So this will be P. And then there is this force 0.2 G, which is 2 Newton. So now let's resolve the R Newton force and the P Newton force. So first we can, in order to resolve this, we can make a small change. R will be here. This will be on the left. What I'm doing is resolving the forces. One force on the left and one force down. So let me make the diagram here again. Yeah. So this is 30 degree, this is 90, and this is R. So let this be Ry and this is Rx. So now what can we do is we can use trigonometry. So this is the opposite side and this is the adjacent side. So according to trigonometry, wait, that is a G, not a D. A, D, J. Perfect. So sine 30 will be opposite upon hypotenuse, which is ry upon r. Cos 30 will be adjacent upon hypotenuse, which is rx upon r. So ry is r sine 30 and rx is r cos 30. So what is rx? Rx is r cos 30. And what is ry? R sine 30. So this is r sine 30. This is r cos 30. Now let's move to P. So there is one force acting on the right and one force acting upwards. So let me redraw this diagram. This is the triangle right here. This is how P is acting. This is 60 degree. And let this be Py, let this be Px. Again, we go. This will be 90 degree. This is the opposite side. This is the adjacent side. So again, if we use trigonometry, we'll get sine 60 is equal to Py upon P. Hence, Py will be P sine 60. Cos 60 will be Px upon P. Hence, if P goes there, it will become P cos 60 equals Px. So now let me label this here. This upward arrow Py will be P sine 60. P sine 60. And this will be P cos 60. Perfect. Now let's label all horizontal forces and vertical forces individually. What do I mean by that? We'll see. Horizontal, vertical. Now which forces are horizontal right here? This force is horizontal r cos 30. It is acting on the left. And this course, this is horizontal. This is acting to the right. So let me write that down. R cos 30 P cos 60. And now we'll talk about the vertical. So let me erase this. This is the first vertical force, R sine 60, acting downwards. This is the second vertical force, 2 Newton, acting downwards. This is the third vertical force, P sine 60, acting upwards. So let me write that down. One is down R sine 30. The other one is 2 Newton, and one force acting upwards is P sine 60. Now that we know that the system is in equilibrium, that means the resultant forces are zero. And if the resultant forces are zero, the force on the left should equal the force on the right. And the force downwards will equal the force upwards. So now let's make equation according to this. R cos 30 minus P cos 30, not 0, is cos 30. R cos 30 will be equal to P cos 30. P cos 60, my bad. This is the first equation that we got from here, 1. And the second equation which we'll get from here is R sine 30 plus 2 is equal to P sine 60. Yes, now we have the two equations. Let's rearrange them. R cos 30 minus P cos 60 is equal to 0. And the other one will be R sine 30 minus P sine 60 is equal to minus 2. Now let me bring out my calculator, because what this is simultaneous equation where R and P are two variables. R and P are two variables. So if I click mode phi and 1, this is the first one is ax plus b plus c, which is technically a simultaneous equation. So first I'll have to write cos 30, then minus cos 60, then 0, then sine 30, then minus sine 60, then minus 2. So the answer I'll get is 2 and 3.464. So 2 and 3.464. So R, the first variable, will be 2 Newton, and P, the second variable, will be 3.464 Newton. And that's how we get our answers. To the fourth question. An elevator moves vertically, not upwards. Just that means if this is a elevator, it can move both up and down. Anyways, it can move. An elevator vertically moves vertically, supported by a cable. Diagram shows a velocity graph which models. Graph consists of 7 straight line segments. What do they mean by straight line segments? This is the first straight line segment. This is the second straight line segment. This is the third, fourth, fifth, sixth, seventh. Okay, so there are 7 straight line segments. The elevator accelerates upwards from rest to a speed of 2 meter per second over the period of 1.5 seconds. So what they explained is this part. Next, and then travels at this speed for 4.5 seconds. Okay. So 1.5 plus 4.5 will be 6. 1.5 plus 4.5 will be 6. So it travels at this constant speed before decelerating to rest over 1 meter. Okay. So that means from here it went to 0 meter per second in 1 second. That's what they are talking about. The elevator then remains at rest for 6 seconds, which they are explaining this, before accelerating to a speed of v meter per second downwards over a period of 2 seconds. So that means this is accelerating downwards to a speed of v, which we don't know now. I guess we'll have to find out in some question ahead. I guess in B, probably, don't know. Let's see. Downwards over a period of 2 seconds. The elevator travels at this speed for a period of 5 seconds. That means for 5 seconds, it is traveling at this constant speed before decelerating to rest over a period of 1.7. Decelerating means it is from negative, it is becoming 0. Find the acceleration of the elevator during the first 1.5 seconds. Okay, first let me erase this mess. What they have asked us is to find the acceleration of the elevator during the first 1.5 seconds. That means during this time, what is the acceleration? So this is a very easy question. We know the initial velocity is 0 meter per second. Final velocity is 2 meter per second. Time is 1.5 seconds. So what we can use is S equals ut plus half at square. And do we know S? No, we don't know. We can't use this. What can we use? V square equals u square plus 2s. No, v equals u. Yes. We can use v equals u plus 80. V equals u plus 80. V is 2, u is 0, a we don't know, t is 1.5. Therefore, 2 equals 1.5a. Therefore, a equals 2 upon 1.5. So 2 upon 1.5, the answer if I put this in the calculator will be 4 upon 3 meter per second, which is 1.1111 meter, 1.33333 meter per second. 1 second. Okay, let's move to the next question. Given that the elevator starts and finishes its journey on the ground floor, find V. Okay. So what I need you to realize here is if we find the area under this graph, because this is a velocity time graph, if I find the area of this section, now here the velocity is positive. That means the elevator is moving upwards. If I find the area of this velocity time graph, that will be, for example, let this be the ground floor. This GF is ground floor, not anything else. So this is the elevator. So the elevator is moving upwards. So this will be between time 0 to time 7. So that means between time 0 to 7, the elevator moves from the ground floor to some distance up here. And after that, what they have told is, given that the elevator starts and finishes its journey on the ground floor, that means That means after this movement, this is negative, right? This is negative. What do I mean by this is negative? The velocity is negative. That means the elevator moved down. So between time 13 to 21.5, time 13 to 21.5, the elevator will move downwards. And how much will it move downwards? It will move the same distance which had moved upwards. For example, if upwards movement was 3 meters, so even the downward movement was 3 meters and it will return to the same exact position. Why? Because they have given that as in the question. Starts and it finishes its journey on the ground floor. So that means the area under this trapezium will be equal to the area under this trapezium. So let's find out now after I erase everything. So first of all, I want you to know what is the area of a trapezium. So let me give you, in case you don't know what is the area of a trapezium, let me give you a brief example. Yeah. So if this is a trapezium right here, if this length is A, B, C, D, and this is E. So the area of the trapezium in words is half into sum of parallel sides into height. So here the parallel sides are B and D. So the area of the trapezium will start with half into sum of parallel sides will be B plus D and height will be A. So this is the area of the trapezium. Now let's move forward. So here the parallel lines are this. So this is this will be 6 minus 1.5, which is 6 minus 1.5 is 4.5. So this will be 4.5 seconds, or distance is 4.5. This is 7. The height is 2. So area of this trapezium, that means distance traveled upwards is equal to half. Sum of parallel sides will be 4.5 plus 7. 4.5 plus 7. And height is 2. Just 2 cancels out. So 4.5 plus 7 is 11.5 meter. So 11.5 meter is traveled upwards. Now we know that this distance, this area or this distance is equal to this area and distance. Both are equal. This area will be equal to this area. So now what we can do is we can simply write 11.5 is equal to what will be this length? This length will be 21.5 minus 13. 21.5 minus 13 will be, if I put that in the calculator, 8.5. So half into 8.5 plus this length, which is 15, 20 minus 15. 20 minus 15 is 5. And what is the height? The height is V. So the answer will be 11.5 into 2. Answer upon 8.5 plus 5 will be 13.5 is equal to V. Therefore, the answer for V is 11.5 into 2. Answer upon 13.5. So the velocity for V is 1.704 meter per second. Now, many of you may have got the answer minus 1.704. Many of you might have got minus 1.704, but that is not the correct answer, because here what we have to find is the value for V, and they have already given minus V here, right? They have given minus V. So in case if you got V as minus 1.704, if you have got V as minus 1.704, And if you input it in here, so minus of minus 1.704 is plus 1.704, and below 0, can this entire value be a plus 1.704? No, it has to be negative. So that's why velocity V, not velocity, capital V is positive here. Why? Because if capital V is positive, if capital B is plus 1.704, then we can write the minus here, the minus that is outside, that let it be outside, and this will be plus 1.704. Hence, the final answer which we'll get is minus 1.704, and we can, this is equal to minus 1.704. This can't be equal to plus 1.04. Hence, the value for V is positive, which is 1.704. Now let's go to the next question. The combined weight of the elevator and passengers on its upward journey is 15,000 kilogram. Okay, that means the elevator which is moving upwards. There are some passengers also. The combined weight is 15,000 kilogram, which is 15,000 Newton downwards. Assuming there is no resistance to motion. Okay, so resistance is 0. Find the tension in the elevator. Now, because one force is moving downwards, and see, the upward journey is 15,000. Sorry, the journey is upwards. That means the elevator is moving upwards. I'll repeat, the journey is upwards. So in order to move the journey upwards, there need to be a tension upwards because there is weight downwards. If there is some tension that can move the lift upwards, then only it can overcome the weight, and then hence the elevator will move upwards. Assuming there is no way to find the tension in the elevator cable, okay, that's what we have to find on its upward journey when the elevator is decelerating. Now, what we need, a very important point here, elevator is decelerating. That means motion is upwards. Motion is upwards, but acceleration is downwards. Now, when motion is upwards and acceleration is downwards, acceleration will be negative. And we know this is an upward journey. So if you want to look in the diagram, we have two options. This is the upward journey. This entire area is the upward journey, and this entire area is the downward journey. So right now there is no need to consider the downward journey at all. We just need to go with the upward journey. And even in the upward journey, we know that the acceleration should be negative. And here we already found out the acceleration is positive here. During the first 1.5 seconds, the acceleration was plus 1.33 meter per second square, not here, square. So here the acceleration will be negative. This is the only part where acceleration can be negative. Why? Because here the acceleration will be 0. Acceleration equals 0 as speed is constant. Speed is constant. So in this 1 second, the acceleration will be negative. And what will be the acceleration? Let's find out. Time is 1 second. Initial velocity was 2 meter per second. Final velocity was 0 meter per second. 1, 2, 0. Okay, let me write that down again. 1, 2, 0. What is the time is 1 second. The initial velocity is 2 meter per second. And the final velocity is 0 meter per second. And what we need to find out the acceleration. V equals U plus AT. V is 0, U is 2, A we don't know, we have to find out 1. Therefore, minus 2 equals A. Therefore, acceleration is minus 2 meter per second square. Now we also know the acceleration is minus 2 meter per second square. What we need to find is the tension. Now, have they told us that about the motion? It is decelerating. Now we know F resultant is equal to mass into acceleration. So F resultant will be 15,000 into minus 2. So the resultant force is minus 3,000 Newton. Minus 3,000 Newton in which direction? Minus 3,000 Newton downwards. So that means we are considering downwards to be positive. Now, let me repeat what we are considering. We are considering downwards to be positive. My bad. We are considering upwards to be positive. Upwards positive. Why? Because acceleration is downwards, that decelerating. The elevator is decelerating. That means even if the even if the motion is upwards, the acceleration will act downwards. That means positive acceleration will be downwards. But if we consider the opposite direction, if we consider the direction of motion, the value of acceleration will be negative. Here the value of acceleration we got negative, and which we applied here. So we got minus 3000. So minus 3000 F resultant. What is F resultant equal to? F resultant is simply equal to T minus 15,000. T minus 15,000. So what is T? T we don't know. Can write minus 15,000 here. Therefore, tension equals 15,000 minus 3,000, which is 12,000 Newton. Let me explain the directions to you again. Here is the elevator. Motion is downwards. Acceleration is upwards. I reversed it. Motion is upwards. Acceleration is downwards. Now, if I consider from the motion point of view, upwards, if I tell you a particle is accelerating downwards at 3 meter per second square, that technically means that if I take the upward arrow, if I tell you particle accelerating downwards at 3 meter per second square, that means the particle will accelerate upwards at minus 3 meter per second square according to vectors. If the direction of arrow is reversed, changed, ulta, reversed, then the sign will also be reversed. This plus 3 will become minus 3. That's what we did here. Because we are considering the upward side to be positive, the upward acceleration in the upward direction will be negative. That's why we got a negative answer here. That's why for resultant force also we got a negative answer, minus 3000. Then we formed the equation. F resultant is T minus 15,000. Why? Because according to the free body diagram we created, this downward force and T, these are the only two forces that are acting on the elevator. So F resultant will be minus 3000 equals T minus 15,000, and hence the value for T we found is 12,000 Newton. And that's what they have asked us to find the tension in the elevator. Let's move to the fifth question. A block of mass 5 kg is being pulled along a rough horizontal floor by magnitude x Newton. Acting at 30 degree, block starts from rest. Okay, that means the initial velocity is 0 meter per second. Travels 2 meter in the first 5 seconds. Okay, that means when time is 5 seconds, the displacement covered is 2 meter. 1 second, let me write the 5 properly. When time is 5 seconds, yes. Find the acceleration of the block. Okay. So first thing which should come in your mind is resolving forces. So this x Newton, let's resolve it quickly. This is x Newton. One force will act to the right. One force will act upwards. This is 30 degree. And this will be sine. Sine 30 is equal to, let this be x. X upon x Newton. So x will be x sine 30. So that is the upward force. So the upward force is x sine 30. The upward force is x sine 30. Similarly, let this be y. So cos 30, this is the adjacent side. So y upon x. Therefore, y is x cos 30. So y will be x cos 30. Now, have they talked about some frictional force or something? Let's see. Yeah, rough horizontal floor. That means this question is about friction. So there will be some friction also. So let us label that as FR, frictional force. Now let's get ahead. find the acceleration of the block. This is very easy because we know that the initial velocity is 0 because it starts from rest. The time in 5 seconds, it covers a distance of 2 meter, or to travel 2 meter, it takes 5 seconds. So we know U, we know T, we know S. So we can use S equals UT plus half a T square to find out the answer. S is 2 meter, initial velocity is 0, so this entire thing becomes 0, plus half acceleration we have to find out, and time is 5. Therefore, 2 is equal to 5 square A upon 2. This 2 will go there. Therefore, 4 upon 5 square is equal to A. Therefore, A is equal to 4 upon 25. And if I put that in my calculator, 4 upon 25 will be 0.16 meter per second square. So the first answer which I found for acceleration of the block is 0.16 meter per second square. Let's move to the next question. Given that the coefficient of friction between the block and the floor is 0.4, that means the coefficient of friction is 0.4. Find x. So what is this FR? FR is nothing but UR, which is 0.4 R. So now we'll have to find what is R. And in order to find out what is R, what we have to do is, we all know that this will be R, and this is 50 Newton. Why? Because the mass is 50 kg. The mass is 5 kg, so weight is mg, which is 5 into 10, because gravity is 10. So weight is 50 Newton downwards, because weight always acts vertically downwards. So R will be nothing but 50 minus x sine 30, the downward force minus the upward force. So R is equal to 50 minus x sine 30. So let's simplify this. If I put 50 minus x sine 30 in the place of R, then I'll get 0.4 50 minus x sine 30. Now further simplifying this, if I put this in the calculator, I will get FR is equal to 0.4 into 50 will be 20. 20 minus 0.2x. That is the value for FR. And now what they have told us to do is, they have told us to find x. X is the force which is acting. So what can we do is, first, F resultant is equal to mass into acceleration. So what is the mass of the object 5 kg, and what is it accelerating at? It is accelerating at 0.16 meter per second. So what we can write is 5 into 0.16. So the answer is 0.8 Newton. Wait, let me check that in my calci. 5 into 0.16. Yeah, that is 0.8 Newton. And we also know that F resultant will be the forward force minus the backward force. So the forward force is x cos 30, which is x cos 30. And what is the backward force? Backward force is FR. So minus FR. Now we know FR. FR is 20 minus 0.2x. This is FR. So instead of this FR, I can write 20 minus 0.2x. I will do that right away. I'll write bracket 20 minus 0.2x. So, and I know F resultant. What is F resultant? F resultant is 0.8. Therefore, 0.8 is equal to x cos 30 minus 20 plus 0.2x. And this is not a small x, this is capital X. So 0.8 plus 20 is equal to x in common cos 30 plus 0.2. This entire thing can go down, which will become upon cos 30 plus 0.2. This is just basic algebra. Now, if I put this in the calculator, then 0.8 plus 20 upon cos 30 plus 0.2, the answer will be 19.5 newtons. 19.5 newtons. And that's how we end question number 9. We end the B question. Let's move to the C part. The block is now placed on a part of the floor where the coefficient of friction between the block and the floor has a different value. Okay, so that means the value of nu has changed. What else? The value of x is changed to 25. Okay, let us start drawing a diagram again. Or should we draw a diagram? Yeah, we should actually. So this is the floor. This is the block. Now what has changed? The value of x. So the value of x has become 25. Okay, and that is at a 30-degree angle. So the value of x is now 25 Newton, and this angle is 30-degree. So first, without doing anything else, let's just resolve the forces. So this is one force, this is one force, this is 90-degree. Let us redraw the diagram. One goes to right, one goes up, and this main force 30 Newton, 90-degree, 30-degree. This is x, this is y, this is opposite, this is adjacent. Sine 30 is equal to x upon 30 Newton. Sine, oh, not 30, my bad, this is 25. So, and this will be 25. And cos 30 is equal to x upon 9, y upon 25. So y will be 25 cos 30 and x will be 25 sin 30. So this x is the upward arrow. Upward arrow is 25 sin 30 and this is 25 cos 30. Let's move ahead. The friction value has changed because there is friction. We'll also have to mention FR. Yeah, FR. And the block is now in limiting equilibrium. Okay, so that means resultant forces are 0. Find the value of the coefficient of friction. Very easy question. Now, here the block has a mass of 50 kg. So 5 kg. So this will also be 50 Newton, same as the previous question. So now this upward force is 25 sin 30. Let me write it here. 25 sin 30. And I'll erase everything. Now this 25 Newton force and 30-degree does not matter to us at all because we have already resolved the forces. These are the resolved forces. So even if we remove it from the diagram, it doesn't matter and we'll save space. And this 25 sin 30 I've shifted and the 50 cos 30 I'll have to mention here, which I accidentally erased. 25 cos 30. So these both forces, if I write it like this, it is equivalent to 25 Newton acting at an angle of 30-degree. These both forces denote the same thing. That's why I just erased that. Okay. And what else? Yes. The contact forces will act upwards are. We'll talk about it later. First, let's start now. So F resultant will be 0. We know that. And what is F resultant? F resultant is the force on the right minus the force on the left. What is the force on the right? 25 cos 30 minus force on the left is FR. Now, what is FR? FR is UR. Now we don't know the value of U, but we can find R. How do we find R now? R will be equal to 50 Newton minus 25 sin 30. So 50 minus 25 sin 30. If I put this in the calculator, 50 minus 25 sin 30 will give me a value of 37.5 Newton. So R is 37.5 Newton. Now if I put this R in place of this, if I put 37.5 in place of R, So I'll get FR equals 37.5 nu. Now let's go ahead. If instead of this FR, I will write 37.5. So F resultant is equal to 25 cos 30 minus 37.5 nu. Now we know F resultant is 0. So I can write this as 0. Therefore, this will go here. 37.5 is equal to 25 cos 30. Nu also. Nu into 37.5. Therefore, nu is equal to 25 cos 30 answer upon 37.5. So the answer will be, if I put this in the calculator, 25 cos 30 upon 37.5. So the answer is root 3 upon 3. Now let's see what they have asked. Just find the value of the coefficient of friction. Okay. So we can write both. Root 3.3 is equal to 0.577. 0.577. Yeah. And that's our answer. Now let's move to the sixth question. The sixth question is about velocity, acceleration, and all integration derivation. A particle moves in a straight line, starts from rest, that means e equals 0. Fixed point, that means displacement is 0 initially. Its velocity at time t after leaving this. Find the displacement. Okay. So right now we have a velocity time graph. And from a velocity time graph, if you want a displacement time graph, then what we need to do is we need to integrate. If you want an acceleration time graph, what we need to do is we need to derivate, and vice versa. If from displacement time to velocity time, then we'll have to derivate. If velocity time to acceleration time, if from acceleration time to velocity time graph, then we'll have to integrate. That's the cycle. So now let's get going. Velocity equals t square minus 8t 3 by 2 plus 10t. Now if I want to find the displacement, what will I have to do is I will have to integrate the velocity time graph. So integral of velocity will give me integral of t square minus 8t plus t dt. So now this will become t cube upon 3 minus 8t 3 upon 2 plus 1 upon 3 upon 2 plus 1 plus 10t square upon 2 and plus c. But they have told that it starts from a fixed point O. O means the origin. That the origin displacement is 0. That means even the c is 0. C is equal to 0 if it is on a fixed point O. Now let's get going. S equals t cube on 3 minus 8t. If I put this in the calculator, I'll get 5 upon 2 bracket 5 upon 2 plus 1 za 5 za 5t square. Now this 2 can go up and 8 and 2 will multiply to give me 16. So 16t raised to 5 by 2 upon 5. What next? They have asked us to find the displacement when t equals 1. So let us input t equals 1 here. So you get s equals 1 cube upon 3 minus 16, 1 raised to 5 upon 2 upon 5 plus 5, 1 the whole square. Therefore s equals 1 upon 3 minus 16 upon 5 plus 5. Now if I put that in the calculator, the displacement which I'll get is 2.13 meter. Let's move to the next question. That was a relatively easy question. Show that the minimum velocity of the particle is minus 125 meter per second. Okay, so let me rewrite the equation. V equals t square minus 8t raised to 3 by 2 plus 10t. Okay, and now what we want to find is the minimum velocity. So let's assume you have a graph, a normal graph. If the graph is like this, let's assume minus 3x square plus 7, so plus 7, something like that. And if I tell you to find the minimum or maximum point, the minimum or maximum point, then how will you find out? What will you do? You will simply derivate the equation, right? You will derivate the equation. So similarly, and we will find a maximum point here after derivating. So right now we have the velocity time graph. The velocity time graph will also look something like this, for example. And we have to find a minimum velocity, which is this. So we'll derivate the equation. So derivating the equation will look something like this. T square minus 8t3 by 2 plus 10t. Therefore, dv upon dt is equal to 2t minus 8t into 3 upon 2, and this 3 upon 2 minus 1. Wait, let me write that in a proper fashion. This will become 3 upon 2 into 8 into t raised to 3 upon 2 minus 1 plus 10. Therefore, now to find the minimum maximum point, at the minimum or maximum point of a graph, the gradient is 0. And after derivating, what we find is the gradient of the graph. So if gradient is 0 at minimum or maximum point, then what I can do is, because I want to find the minimum velocity, I can equate this to 0, because this is technically the gradient. So 0 equals 2t minus 1 za 4 za. So 3 4 za is 12. T raised to 1 by 2 plus 10. Now I will let x be equal to t raised to 1 by 2. Therefore 0 is equal to 2x square. Now hold. How? Why? Because x is t raised to 1 by 2. So x square will be t raised to 1 by 2 the whole square, which is 2 to cut 1, which is t. And instead of this t, hence I can write x square. So 2x square minus 12 t raised to 1 by 2 is x. So instead of 2 raised to 1 by 2, I can write x plus 10. Now putting this in the calculator, how I can do this is mode setup, phi equation, and this ax square plus bx plus c, the third option. I'll click that, and 2 minus 12, 10. Okay, so the answer is phi or 1. So x equals phi or x equals 1. Now we can't go with x individually because x does not mean anything to us. What means to us is t. So instead of x, I will write t raised to 1 by 2. Why? Because x is equal to t raised to 1 by 2. Same here, t raised to 1 by 2 is equal to 1 is equal to 5. Therefore, t will be equal to 5 square. Therefore, t is 25 seconds, or t is equal to 1 square and t is 1 second. And now what else? What do we have to do? We have to find the minimum velocity. Now we have the velocity equation. One second, let me check. T square minus 8t raised to 3 by 2 minus 8t raised to 3 by 2 plus 10t. Now we'll input t equals 25 and t equals 1 individually. First, let's input t equals 1. So if we put t is 1, therefore velocity will be equal to 1 minus 8 plus 10. The answer is 10 plus 1 is 11, 11 minus 8 is 3 meter per second. Okay, but we have to show the minimum velocity is minus 125. So the answer should be 125. So 1 is not the possible option. Let's go to 25. V equals 25 square minus 825 raised to 3 by 2 plus 10 bracket 25. If I put this in the calculator, we get 625 minus 8 bracket 25 raised to 3 by 2 will give me 1000 plus 250. Now 625 minus 1000 plus 250. If I put yes, I got the answer. The velocity is minus 125 meter per second. So hence I showed that the minimum velocity is this much. My answer is proven. Next question. Oh my God. This looks like an English exam rather than a mechanics paper. Let's start. Two particles of masses 0.5 kg and mkg respectively are attached to the ends of a light inextensible spring. The spring passes over a fixed pulley, which this is two inclined planes. Particles initially at rest. Okay, important point. U is 0 meter per second. U is the initial velocity. Inclined angle 30 degree, 40 degree. String is taut. Taut means the string will not extend. The string is acting like a stick. S-T-I-C-K. The string will act like a stick. That means if one object moves, the other compulsorily has to move the same distance at the same acceleration at the same velocity. Let's move forward. Particles can move on the greatest line of slope. Force of magnitude 0.8 Newton applied to P. Okay, that is shown in the diagram, causing P to move down the plane. Okay, so P moves down the plane. Now P is smooth. This is smooth. And Q is also smooth. So this is also smooth. So according to this question, this is not about friction. This is just about forces. So there will be no friction, no FR, no coefficient of friction here. And given that M is 0.3 kg, okay. So I can cut this M and I can write 0.3 kg. Find the tension in the string. Okay. So what did I talk about tension? The thing about tension is it should move in the opposite direction, like this. So if there are two particles, the tension will always act inwards, such that the two tension can touch each other. You can think of it as if this moves ahead and if this moves ahead, then they can touch. That's how the arrows of tension should be. Now, without further ado, let's get going. We have to find the tension in the spring. So this is a very easy question. Just be with me and listen. This will be 5 Newton downward force due to weight by mass is 0.5. Weight will be mg, which is 0.5 into 10, which is 5 Newton. So this downward force acting due to the weight will be mg sine theta, which will be 5 sine 30. The force acting due to the weight perpendicular to the slope will be 5 cos 30. Going to this downward will be 3 Newton. Force acting down due to the slope will be 3 sine 45. Force acting perpendicular will be 3 cos 45. I hope you are clear with this. This is a concept about mg sine theta, mg cos theta, nothing else. If you want the proof, you can Google it, you'll get it. The proof is also very easy. Find the tension in the spring. Okay, so now, do we have all the forces right here? Yes. Do we know the acceleration, anything? In that time, no. But one thing I need to mention here is if P moves 0.3 meter down, I'm just giving an example. If P moves 0.3 meter down, then even Q will move 0.3 meter up, exactly 0.3 meter up. And the velocity, for example, after 0.3 meter is 10 meter per second. Then even this will be 10 velocity will be 10 meter per second. If the acceleration here is 20 meter per second square, then even the acceleration here will be 20 meter per second square. Do you understand? So both will have the same movement, we can say. Velocity, acceleration, and the distance traveled. Both will be the same. It is just like, I'll give you a very basic example. It is like, assume you have a table here. You have a table. On the table, let me use a different pen. Yes. You have one box. You attach a stick to it, and use another box. And then push this box. So the velocity at which box A will travel will be equal to the velocity at which B will travel, right? because both are attached together. This is the same case. Why? Because here we are given that these strings are inextensible and the string is taut. Inextensible means the string will not extend. For example, if you have a spring, not a string, a spring. If you put on a pendulum, then the spring will go down, right? Like this. It will become something like this. So this is not the case here. The string will not extend, the string will move as it is, like a stick. So now that you are clear with this, let's go ahead. Let me erase everything. So what we have to do is you have to find the tension. So let's resolving forces for P. Not resolving actually, equating. And what do I mean by that? You'll see just in a second. See, so what are the forces acting here? This is tension. What have I written here? Yeah. Then this is tension. So the forces acting parallel to the slope on P are this. Two forces acting on the left and one force acting to the right. And which is positive? This one. The force acting downwards. So 5 sine 30 plus 0.8 minus T. This is the resultant force acting on P. And we also know F resultant is equal to mass into acceleration. So what is the mass of P? The mass of P is 0.5. Acceleration, we don't know, haven't mentioned. So instead of F resultant, I can write 0.5a. So now I have the first equation. Let me rewrite the first equation. I will take T there. So I'll get T plus 0.5a is giving me 5 sine 30 plus 8. This is my first equation. Now let's equate force for Q. So equating forces for Q. So this direction will be considered positive because here we considered this positive. So this and this correlate to each other. So it shouldn't be that the positives, what are you taking as positive should not change in the entire question. So this T will be positive. So these two are the only forces acting parallel to the slope T and 3 sine 45. So T minus 3 sine 45 will be the resultant force. T minus 3 sine 45 will be the resultant force. And we also know F resultant is mass into acceleration, which will be 0.3 A. So instead of F resultant, I can write 0.3 A. Now, notice here I used the same acceleration variable and same tension variable. It is not like if this is 0.5 kg and this is 0.3 kg, both will have different value of T and different value of A. No, the string is taut. The string is like a stick. If one moves, the other moves with the same velocity, same acceleration, everything. So that's why the value for the variables T and A are same because they will be the same. The answer for both of them will be the same. So now I have my second equation. Let me rewrite here. T, I will take 0.3a there and 3 sine 45 on the right. So T minus 0.3a will equal 3 sine 45. And because I took 0.5a there, no, nothing will be negative. So yeah, let's go forward. This is my second equation. T minus 0.3a equals 3 sine 45. Now let me equate 1 and 2. So what do I mean by that? Let me rewrite it here. Let me rewrite it. First equation, t plus 0.5a is equal to 5 sine 30 plus 8. If I let me put that in the calculator, 5 sine 30 plus 8, that will give me 10.5. And second equation is t minus 0.3a is equal to 3 sine 45. 3 sine 45 will be 2.12. Now these both are simultaneous equations. I can equate to find both t and e. Even though the question is just asking for t, I can find both t and e using this method. So in case in some other question, if they ask for t and a, both, you can use this also. And this is a little bit easier method because we can visualize it and the chances of silly errors are a little bit lesser. 1 minus 0.3, 2.12. Yeah. So the answer is 5.263. So the value for T is 5.263 and the value for A is 10.48. Even though this is not required, we can just write it down. T minus. Yeah. So now we are done with this question. Let's move forward. Oh, there is a B question also. Yeah. So let's start reading this question. This is it is given, but instead of Q is okay. It is given instead that the plane on the Q rest is rough. Now what does that mean? Everything will remain the same. Let me just clear everything out. All of this mess. Which is rough? P or Q? Q is rough, right? Yeah, Q is rough. That means here this will be tension. That means one more force will act now. This will be the frictional force, Fr. And because the ball is moving upwards, the frictional force will act downwards. Because the frictional force has to oppose the movement of the ball. So in order to oppose the movement, it has to act in the opposite direction. After each particle has moved 1 meter, okay, so the distance is 1 meter. What we need to realize, what we need to remember is zero. Initial velocity is zero. That will also be important to us. After 1 meter, the final velocity becomes 0.6 meter per second. The work done against air friction or resistance is 0.5 joule. Okay. Use an energy method. Very easy question. Once you see this, do nothing, close your eyes and write this equation first. Work done driving force equals delta K, delta GP plus work done against resistive forces to find the value of M. Okay. Now this value of M was only for part A. Now we don't have the value for M. So now what do? We find the value of M. How do we find it? Let's see. What is the work done by the driving force? And I guess you may not even know what is the driving force. So the driving force is 0.8 Newton. Why? Because is someone the force of magnitude 0.98 Newton is applied to B. Is it being applied because of the weight? Is it being applied due to something else? No. Some person or some machine may be pushing it 0.8, right? That's what is driving the P and Q. In the first question also, part A, that's what drove zero. Because of the 0.8 Newton only, the P was moving downwards and Q was moving up the slope. So the 0.8 Newton is the driving force, not DF, FD, force driving. Yeah. So work done by driving force equals force into distance. So we know the force was how much? Force is 0.8 Newton. Okay. And what is the distance? The distance covered is 1 meter. Therefore, work done by driving force will be 0.8. What about the delta K? Now, what I need you to realize is that they have written after each particle has moved 1 meter, their speed is 0.6. That's what I said before. That both particles will have the same distance traveled and same speed. So that means as this is traveling 0.6 meter. How many meter? 1 meter, 0.6. So let's assume this is 1 meter. The distance traveled will be 0.6. And if so, even this will travel 0.6 meter. And the distance traveled will be 0.6 meter per second. Velocity will be 0.6 meter at the end, at here and at here, when the particle ball reaches here. So now we have to find the change in kinetic energy. So delta Ke is nothing but the final Ke minus initial Ke. So what is the final K? The final K will be half into 0.3, 0.3. What is 0.3? 0.3. No, we don't know 0.3. My bad. It was 0.5. 0.5 is the mass of particle P into. So disclaimer, K is half mv square into 0.6 square final K minus plus half into m into 0.6 square. How did this come from? This is for particle P, okay. And this is particle Q. So both are moving, both have kinetic energy, both have gained kinetic energy. So this is particle P, this is particle Q, okay. And initial kinetic energy will be 0 for both because both start at rest. So V will be 0 for everything. So half into m into 0 will always remain 0 only. So kinetic energy is 0. So now I can simplify this by writing half 0.6 square as common, and I'll write 0.5 plus m. And even further simplifying this, if I put half into 0.6 square in the calci, I'll get 0.18. 0.18, 0.5 plus m. Further simplifying this, 0.18 into 0.5, I'll get 0.09. So 0.09 plus 0.18 m. So the delta Ke is 0.09 plus 0.18 m. I hope you understand why we did plus here, because this is the kinetic energy of P and this is the kinetic energy of Q, and not any kinetic energy, the final kinetic energy and the final kinetic energy of P and the final kinetic energy of Q. Now let's move to GP. So before continuing, I want you to realize one thing, that Q, this particle, is moving upwards. That means its height is increasing. So the GP will be positive for this, obviously. But this particle is moving downwards. So GP will be negative. Why? Because if there is a ball at height 50 meter, if the mass is 10 kg, so its initial GP will be m 10 into g, gravity is 10, m into g into h. Height is 50. So 10, 5,000 joule. But let us now do another thing. If the ball is dropped down at 20 meter, so now the new GP will be 10 into 10 into 20, which is 2000 joule. So now the GP has decreased. So that means the delta GP, which is the final minus initial, will become 2000 minus 5000. And so the GP has decreased by 3000 joule, right? So similarly for this case, earlier the height was this much, but now the height has decreased to only this. So because of the decrease in height, the GP will decrease. So now let's This is very messy now. Let's make another diagram. So the other diagram will look like this. Let me erase everything here. Eraser. Yeah. Okay. So I just want to see the angle. This is 45 and this is 30. So I will draw this here. This is 45. I'll add a partition in between. This is looking like Mount Everest, but it is not. This is a plane, not a paper plane, not an aeroplane, an inclined plane. Jokes aside, this, let P be here, let Q be here. Let this much be 0.6 meter. I mean 1 meter. And this be another 1 meter. Okay. So now, if I want to calculate the height, this is the height for P, this is the height for Q. So how will I? Very easy, I'll use basic trigonometry. This is opposite side, so sine 30 is equal to the height for P upon 1. So the height for P is nothing but 1 sine 30 is simply sine 30, which is 0.5 meter. This is for Q. If we use this triangle, this is the opposite side. So sine 45 is the height for Q upon the hypotenuse side, which is 45, which is 1. So if it goes ahead, this will become 1 sine 45. So height for Q is sine 45, which if I put in the calculator, sine 45 becomes root 2 by 2. Okay, so now we have the heights. Now we know that the particle P is going down. Particle P going down. Hence, Gp decreases. The particle Q is going up. Hence, its Gp increases. So let's keep that in mind and go ahead. So delta Gp will be initial K Gp minus final Gp. So yeah, Gp for P, which is this one P. So Gp for P will be mgh. The mass is 0.5. Gp will mgh. Mass is 0.5. Gravity is 10. And what will be the height? The height will be 0.5, right? No. No. The height will be minus 0.5 because it is going down. So it becomes minus because we want Gp in negative. So this will become minus 0.5. And let's talk about Gp for Q. This is also equal to mgh. Mass of Q we don't know. The gravity is 10. And this is going up. So the height is root 2 by 2. This is root 2 upon 2. This is 0.5 into root 2 upon 2. 1s are 5s are. Therefore, this is equal to 10, 5, 5 minus 2.5 joules. This is equal to 5 root 2 joules. Now we also know delta GP. Delta GP is equal to 5 root 2 minus 2.5. And what is the work done against friction? The work done against friction in this part is 0.5. So we already know the answer 0.5. Now we can erase. No, there is no need to erase actually. We know we can find m using here. Did I miss something? Yes, I did. This is, I forgot the m. This should be 5 root 2 m joule. So this will become 5 root 2 m minus 2.5. Now we can take out all the variables there, which will become 0.8 minus 0.09 plus 2.5 minus 0.5 is equal to 0.18 n plus 5 root 2 n. Let me box that out. So if I put this on the calculator, 0.8 minus 0.09 plus 2.5 minus 0.5 will give me 2.71. So using a black pen, 2.71 is equal to 0.18 plus 5 root 2. So m 0.18 plus 5 root 2. And this goes down, which will give me 0.18 plus 5 root 2. I can erase this. So therefore, the value for m will be 2.71 upon 0.18 plus 5 root 2. So the value for m is 0.374 meter. Kg. Value for m is 0.374 kg. That means the mass of Q is 0.374 kg. And that's how we end this question. And that's how we end the paper. Thank you for watching.